Good evening, students. So last class we were discussing about structure of atom. So we have completed the quantum mechanical. We have completed the line spectrum of hydrogen, right? So these were the things which we were discussed earlier. So we have completed electromagnetic radiation. So we have discussed what is the wave nature of electromagnetic radiation, and we have also studied the particle nature of electromagnetic radiation. Then based on this, then we have seen the characteristics of a wave. So the different characteristics like wavelength, frequency, wave number, right? So this we have discussed velocity. So these are the characteristics which we have discussed about the wave. Then what is electromagnetic spectrum? Okay, what is electromagnetic spectrum? Then we have discussed about the particle nature of electromagnetic radiation. So particle nature, it explains two phenomena. One is the black body radiation and another is the photoelectric effect. Okay, so how do you calculate photoelectric effect? So the kinetic energy can be calculated as half mv square is equals to h nu minus h nu naught. Okay, where nu naught is the minimum frequency which is required to eject electron. So this mu naught is nothing but it is called as the threshold frequency. So threshold frequency, it is the minimum frequency required to eject electrons. Okay. So based on the electromagnetic radiation, also we have solved some questions in our last class. Then we had started with line spectrum of hydrogen. So line spectrum of hydrogen, so different spectral lines we have discussed, Lyman series, Balmer series, Paschen, Brackett, Pfund series, right? So based on this, also we have solved some problems. Then Bohr model of an atom. Okay, how to calculate the radius, energy of different stationary states, how to calculate the number of spectral lines, right? Then we have discussed about the limitations. Okay, what is Zeeman effect? What is Stark effect? So based on Bohr's model also, we have discussed some numericals. So I think I have stopped here. So this is the problem which I have to solve. So when the electron of a hydrogen atom jumps from n is equals to 4 to n is equals to 1 state, the number of spectral lines emitted is. So what is the number of spectral lines which is emitted? Okay, so A15, B9, C6, D3. So we have seen the formula how to calculate the spectral lines also, right? So what is the formula to calculate it? So now spectral lines, okay. So the electron, okay, somebody has answered. Okay, Sri Varuni has answered it as C. Okay, so we'll see here. So what they have said that the electron of a hydrogen atom is jumping from n is equals to 4 to n is equals to 1 state. Okay, so electrons jumps from n to gs. Okay, that is from excited state to ground state. So your n is equals to 1 and your excited state is n is equals to 4. So number of spectral line, okay, number of spectral line can be calculated as n into n minus 1 by 2. Okay, so E electron is jumping from stationary state 1 to n is equals to 4. Okay, so here what is n now? 4. So 4 minus 1 divided by 2. So 4 into 3 divided by 2, 12 by 2, that will be equal to 6. Yes, so correct answer is 6. So this is the formula which we are going to use for spectral lines. Okay, so based on this, so next problem which we are going to solve. So next is we are going to start with a quantum mechanical model of atom. Okay, so what is quantum mechanical model? Yes, what is quantum mechanical model? So quantum mechanical model, it Okay, so it is based upon two important concepts. The first one is the Heisenberg uncertainty principle. Okay, the first one is Heisenberg's uncertainty principle, and the second one is dual behavior of matter. Okay, the second one is dual behavior of matter. Okay, now first we'll discuss about Heisenberg's uncertainty principle. So what does Heisenberg, he gave the principle. He said that it is impossible to determine simultaneously both the position as well as the momentum of an electron. So whenever this you are determining, you want to determine the exact position and momentum. Okay, so at a simultaneously means at particular time. Okay, so at one time, at one instant, you cannot calculate both. So it is impossible to determine simultaneously both the exact position and exact momentum of an electron. So it is the mathematical expression to calculate Heisenberg's is given as delta x into delta p, okay, which is greater or equal to h by 4 pi. So this delta x is nothing but uncertainty in position. Okay, it is uncertainty in the position, and delta p. So delta p, you know what is p? P is momentum. It is given as mass into velocity. So delta p is what? Delta p is the uncertainty in momentum. So this can also be given as m into delta v. Okay, so this is the way you are going to. So what I'll do, delta p, m is equals to delta v. So in the further, delta x into m into delta v greater or equal to h by 4 pi. Okay, 4 pi. So this is the equation that is based on uncertainty principle. So at an instant, that is the exact position and the momentum of an electron cannot be determined simultaneously. So this is Heisenberg's uncertainty principle. So next we are going to see the dual behavior of matter. So as with respect to electromagnetic radiation, okay, as we had discussed about electromagnetic radiation, so as electromagnetic radiation, they have both, it behaves both as particle-like and it behaves both as particle-like as well as the wave-like behavior. So those matter also has the dual character, that is it behaves like a wave as well as the particle. So this wave which is associated with the particle, it is called as de Broglie's wave. So this is given as de Broglie's equation. So de Broglie, he gave his equation as lambda is equals to h by mv. H is the Planck's constant. So you know what is mv? Momentum is equals to m into v. So I'll write h by p. So lambda is equals to h by p. So this is de Broglie's equation. So as electromagnetic radiation has dual character, matter can also be considered having dual character. So next we are going to solve some questions, okay, based on uncertainty. So uncertainty in position of a minute particle of mass 25 grams in space is 10 raised to minus 5 meter. The uncertainty in its velocity, that is in meter per second, is. So they have asked what is the uncertainty in velocity. So we know the equation, mathematical equation. So the mathematical equation for uncertainty is given as delta x, okay, into m delta v greater or equal to h by 4 pi. Okay, now what all is given, I'll write it down here. Okay, what all is given. So uncertainty in position is given. So uncertainty in position is given as 10 raised to minus 5 meter. Mass is given, mass is 25 grams. Then Planck constant is 6.6 into 10 raised to minus 34 joule second. What I have to find is delta V. Okay, delta V I have to find. So what all the given things are there, I'll just substitute them. Okay. So how do I substitute now? So just see. So delta X, what is delta X? It is 10 raised to minus 5 meter. Okay, into what is mass? Mass is 25 grams. So 25 grams, I have to convert it into kg because the other units, okay, joule second joules can also be written as kg meter square, okay, second per square. So this second get cancelled and it becomes only per second. So it will be what? It will be per second. Okay. So joule second can be written as kg meter square per second. Now, so kg, so I'm converted into kg, that is 25 into 10 raised to minus 3 into delta V greater or equal to H is 6.6 into 10 raised to minus 34 divided by, so joule second, I'll write it as kg meter square per second. What is 4? What is pi? 3.14. So what is the unknown here? Unknown entity is what? Unknown entity is which is the unknown entity here? So which is a unknown entity here? Sorry, there was some miscommunication. Okay. So which is the unknown quantity here? Unknown quantity is here 10 raised to, okay, this is, so 10 raised to, that is delta V is the unknown here. Okay, so how we will take it now? So this is the unknown. So what I'll do now, these two, okay, these two, I'll shift it here, okay, it to the denominator. Okay, so how it will be now? Just see. Just see what will be the answer. I'm not able to use my writing. Just a second. Mhm. So just shift this to 10 raised to minus 5 and 25 into 10 raised to minus 3 to the denominator. Okay, that is 4 into 3.14 into 10 raised to minus 5 into 25 into 10 raised to minus 3. So you will get what is delta V. Just see what answer you will get for delta V. See what answer you are getting for that.
Option A.
Yeah. Option A. No, see here. Now this will become, so if you transfer here, I'm not able to correct it now. Just a second now. So this, what I'll do, this I'm shifting here. So now it will be, so this will be delta V, okay, greater or equal to 6.6 into 10 raised to minus 34. Okay, this will be kg meter square per second divided by, so this 10 raised to minus 5. So this will be 10 raised to minus 5. I'm not able to. So into 25 into 10 raised to minus 3 kg, this will be, okay, and into 4 into 3.14. So now this kg get cancels, okay, then 10 raised to minus 5 is meter, so this meter and this 1 meter get cancelled, okay, then we are left with meter per second. So what you do now, so this is 10 raised to minus 5, this is 10 raised to minus 3. So this will be 10 raised to minus 7. So 10 raised to minus 34 and up 10 raised to, so this becomes 7. So just see, it will be, what, just see. So it will be 27. Right, 27. So it will be minus 27. Now, after solving this answer, you will get it as, first you will get the answer as 0. Just see, after solving this, you will get the answer as 0.0210 into 10 raised to minus 26 meter per second. Okay. Now what I'm going to do, I'm going to shift this by 2 decimal by 2. So this will be, so 26, it becomes 28. So 2.1 into 10 raised to minus 28 meter per second. So velocity, you know that it is given as meter per second. Okay. So this is the way you're going to solve it. Then, so we'll go for the next question. So one more question, you have to find here the change in So next question, uncertainty in position of an electron. So we have to find the uncertainty in position of an electron. Okay. So the electron mass is given as 9.1 into 10 raised to minus 31 kg, which is moving with a velocity of 300 meter per second, which has an accuracy up to 0.001%. Okay. Now here you have to find the uncertainty in position. You know the formula, delta x into m delta v greater or equal to 4, h by 4 pi. What all is given? Okay, now given things. So uncertainty in velocity, that is position, is x. So that we don't know. So x is equals to don't know. Then electron, mass of electron is 9.1 into 10 raised to minus 31 kg. Then which is velocity is given as 300 meter per second. Then accuracy, that is accuracy is given as 0.001%. Now so what you have to do first, velocity is given, they have not given the uncertainty in velocity. So how you have to do, so uncertainty of velocity is, so percent accuracy is given, so 0.01% means 0.001 into 100, and this you have to multiply by 300. So after solving this, you will get it as 3 into 10 raised to minus 3 meter per second. So this is the uncertainty in velocity. Okay, now you have to put this value here. So all the values, you just put it in the formula. So delta x is what? Delta x is we don't know. Then mass is what? Mass is 9.1 into 10 raised to minus 31. What is delta V? 3 into 10 raised to minus 3. Okay. And then greater or equal to 6.6 into 10 raised to minus 34 divided by 4 into 3.14. So now what is unknown here? Yes, what is unknown here? Here unknown is the delta x, that is change in velocity. So how it is given? So how we are going to do now? So keep it here and these two things you transfer here. So this will be 9, this will be what? So this will be 6.6 into 10 raised to minus 34. This is delta x greater or equal to divided by 9.1 into 10 raised to minus 31 into 3 into 10 raised to minus 3. Okay, into 4 into 3.14. So this is 9.1 kg. This is kg. This is kg meters square per second. Okay, then 3 into 10 raised to minus 3. That is what? This is the velocity which is given as meter per second. Okay, now we will cancel the similar terms. So kg and this kg get cancelled. Meter cancel. Per second cancel. Okay, we are left with only meter. So delta x, that is position, is calculated in delta x. So delta x, if you solve this, that is 6.6 into 10 raised to minus 34 and divided by the whole, the answer at the last you get it as 0.0192 into 10 raised to 3. So if I shift this decimal by 2, so this will be now delta x is equals to 1.92 into 10 raised to minus 2 meter. So our answer is what? 1.92 into 10 raised to minus 2 meters. So option number C. Okay, option number C. So like this, you have to use the formula for uncertainty and you have to calculate the answer. I hope it is clear. Okay.
Yes, ma'am.
So next we are going to start with the quantum numbers. So what are quantum numbers? So each orbital in an atom is specified by a set of 3 quantum numbers, that is n, l, and m. And these each electron, okay, is designed by a set of 4 quantum numbers, that is n, l, m, and s. So each orbital in an atom, it is specified by 3 set of quantum numbers, that is n, l, and m. And each electron in that orbital, it is designed by a set of 4 quantum numbers. That is, it is also associated with the spin of the electron. Okay. So, so there are 4 quantum numbers. So we will see each of them separately. So the first one is principal quantum number. So principal quantum number, it is given as small n. So what it tells you about the size and energy of the orbit. It tells you about what? It tells you about the size and energy of the orbit. Then what are the possible values of n? So the possible values of n are n is equals to 1, 2, 3 till infinity. So what is n? When n is equals to 1, it represents your K shell, the main shell. Okay, it represents your main shell. Then n is equals to 2, it represents the L shell, and etc. M, N, etc. Okay, so this represents the main shells. Okay, so maximum number of electrons in the particular shell, how it is associated or how it is calculated, it is given by 2n square. Okay, how it is given? It is given by 2n square. So this is the formula to calculate the principal number, that is to calculate the number of electrons in a particular shell. So next we are going to start with the azimuthal quantum number of a second quantum number. So that is a angular quantum number. It is called as angular quantum number. So it tells you about the subshells. So what is that? Principal quantum number, it tells you about the main shell. Then azimuthal quantum number, it tells you about the subshells, and it tells you about the shapes of the orbitals. Okay, it tells you about what? It tells you about the shape of the orbitals. So for a value of n, so when you have a particular value of n, then when that is L is equals to 0 to L is equals to n minus 1, Then value of L, if it is 0, the name of the subshell will be S. If the value of L is 1, the name of the subshell is P. If the value of L is 2, then name of the subshell is D. Okay, if the value of L is 3, then the name of the subshell is F. So the shapes are respectively for S subshell, it has a spherical shape. For P subshell, it has a dumbbell shape. For a D subshell, it has a double dumbbell. And for F subshell, it has a complex shape. Okay. So here in azimuthal quantum number, it represents your orbital angular momentum. So orbital angular momentum can be calculated as h by 2 pi square root of L into L plus 1. So this is the azimuthal quantum number. Okay. So next is magnetic quantum number. Magnetic quantum number is given as ME. So it tells you about the number of orbitals which are present in any subshell. So what it tells you about the number of orbitals which are present in any subshell. For a given value of L, so it can have a values ranging from L minus 1, that is minus L, to plus L, that is including 0. Suppose, so for a given value of L, okay, if you have a value of L, then the total number of value of M will be equal to 2L plus 1. Then the maximum number of electron in a subshell can be calculated as 2 into 2L plus 1. Okay. So this is the way you're going to calculate the magnetic quantum number. Then spin quantum number, which is represented by small s. The value of s is plus half and minus half. So this tells you whether the electron is spinning in anti-clockwise or clockwise direction. So if it is a plus, it will be clockwise. If it is minus half, then it is anti-clockwise. So this is it tells you about the spin quantum number. So, we'll solve some questions based on quantum numbers. So which of the following sets of quantum number is correct for an electron in 4f orbital? So what they have given, so there is you have to tell the sets of quantum number for an electron which is present in 4f orbital. So how do you calculate it? So when you have 4f, okay. So when you have a 4f orbital, and in that you have to calculate for n is equals to, that is for electron, okay, for one electron which is in 4f orbital. So n will be, what is the subshell? N is principal quantum number is 4, okay, because this represents the principal quantum number. So 4, and n is equals to 4. What will be L? L will be from plus minus L to plus L. It includes 0 also. So this is, if it is n is equals to 4, then L will be minus. So this will be 0, 1, 2. Okay, so this will be 0, 1, 2, 3. Okay, 0, 1, 2, 3. Fine. Then what about M? How about M? So M will have the values, that is 2L plus 1. Okay, it will have it 2L plus 1. So if if I put L is equals to 2L, that is 0 plus 1. So this will be M. So M is equals to 1. So we are seeing for only one electron, right? Now S will be equal to half. So this is for the spin. So if N is equals to 4, L is equals to 3. Okay. Then M is equals to 1 and S equals to half. So it will be option number A. So option number A will be our right answer. Okay, so like this, you have to calculate the set of quantum number for one electron. So like this, you are going to solve it. Which of the following okay. So which of the following sets of quantum number represents the highest energy of an atom? So they have given 4 sets, okay, of quantum numbers. You have to tell which among the following set is a it is representing the highest energy. Okay. Now when n is equals to 3, when n is equals to 3 and L is equals to 0, 1, 2, M is equals to 1, and S is equals to half, then what it is? This will be 3D. Okay, this will be 3D. So n is equals to 3, L is equals to 2, that is 0, 1, 2, 3. And for 1 electron, if it is so, then this is n is equals to 4, L is equals to 0. When L is equals to 0 means it will be S subshell. So this will be 4S. Okay. Now here again, L is equals to 3, L is equals to 0. So again, this is also 3S. Then when n is equals to 3 and L is equals to so this will be 3p. So which will have the highest set of energy? It will be 3D. So option number A will be our correct answer. I hope you have got it. Yes. So just see first this. You have to just see, look till here. Okay, this will only crack your answer. So n is equals to 3 means it represents the main shell, and n is equals to 0, it represents your so L is equals to 0 means S, L is equals to 1 means P, okay, 2 D, then S is equals to 3 F, like that. Okay, I hope you have got it. Okay, so we'll go for the next one. The quantum numbers plus half and minus half for the electron spin represents. So what it tells you, quantum numbers plus half and minus half, what it tells you, just go to the answer, sorry, options and see. It tells you about the rotation of electron in clockwise and anti-clockwise direction, or it tells you about the rotation of electron in anti-clockwise and clockwise direction. Plus half means it tells you about clockwise. Minus half means anti-clockwise. It tells you about magnetic movement of electron pointing up and down. And D, two quantum mechanical spin states which have no classical analogs. Yes. It tells you about the rotation of electron in clockwise and anti-clockwise. Okay, it tells you about the rotation of electron in clockwise and anti-clockwise. So option A will be the correct answer. So next is nodes. So the next is nodes and this, okay, nodes and rules for filling electronic configuration. So what is a node? So node, it is a region where the probability of finding the electron is 0. Okay. So what is a node? That is, it is a region where the probability of finding the electron is 0. So two types of nodes are there. One is the radial node. Second is the angular node. Okay. Now, what do you mean by radial node? So radial node, it is a spherical surface region. Okay, where the probability of finding electron is 0. So this radial node, it depends upon two things. One is the principal and azimuthal quantum number. Okay. So the formula, it remains like this. The number of radial node can be calculated as n minus L minus 1. Okay. So this is a formula to calculate the radial node for 1s. Suppose I have to calculate for 1s. So for 1s, you know that n is equals to 1 And what is S? L is equals to 0. So I'll put this values here, that is N minus L minus 1. N is equals to 1 minus 0 minus 1. So this is what? This will be 0. Okay, so this will be 0. So the probability of finding the electron is 0. So like this. Now for suppose I'm finding for P, 2P. Now what is N? N is equals to 2. L is equals to 1. Okay, so 1. Then for 2D, 3D, suppose N is equals to 3 and L is equals to 2. Like that. Then you have to use this formula. So that is N minus L minus 1. So N is equals to 2, L is 1, minus 1. Again 0. So always the probability of finding the electron will be 0. So again here I'll just check. So N is equals to 3, L is 2, minus 1. 3 minus 2 is 1. 1 minus 1 is 0. So probability of finding the electron is 0. So this is the formula you have to use. Next is angular node. So what do you mean by angular node? The planes or planar areas which is around the nucleus where the probability of finding the electron is 0. Okay, this depends on mostly on azimuthal quantum number. So it directly depends on L. Okay, the number of angular node, it depends upon the L. Then total number of nodes. Okay, now if you want to calculate the total number of nodes, so total number of nodes. So total number of nodes N minus L minus 1, okay, plus L. We have to add, so this will be N minus L minus 1 minus L. So, sorry, plus L. So this plus L minus L get cancelled, so N minus 1. So this is the formula to calculate. N minus 1 is a formula for calculating the total number of nodes. Okay, I hope you have got it about nodes. So next we are going to see about Aufbau principle. Okay, so these are some of the rules for filling up the electrons in the electronic configuration, according to electronic configuration. So what is Aufbau principle? So orbitals are filled in order of increasing energy. So you can see this 1s2. So the electrons, how they are filled? First the electrons are filled in 1s2. Then it goes to 2s2. And then it comes to 2p, 3s. Then it comes to 3p, 4s. Then it comes to 3d, 4p, 5s. Then it comes to 5d, 5p, 6s. 4f, 5d, 6p. Then 5f and 6d, like this. Okay, so this is the way the electrons are going to be filled. So orbitals are filled in order of the increasing energy. So, so this is the Aufbau principle. So the next rule is N plus L rule. Okay, N plus L rule, it predicts the energy of the orbital. It tells you about what? It predicts about the energy of the orbital. Then if two orbitals, if they have same value of N plus L, suppose there are two, if the value, okay, suppose if the two orbitals, they are having same value, that is N plus L value is same, then you have to check for the orbital which is having lower value of N. Okay, then it has a lower energy, like this. Okay. So next is Pauli's exclusive principle. Pauli's exclusion principle, an orbital can accommodate at the most two electrons with the spins they are opposite to each other. So this is Aufbau principle. Pauli's exclusion principle. What does Pauli's exclusion principle state? Pauli's exclusion principle states that the whenever you are filling up the electrons in an orbit, okay, no two electrons will have same spin. Okay, or what is that? No two electrons in a orbit will have same set of 4 quantum numbers. Okay, it will not have the same set of 4 quantum numbers. Okay, so this is about the Pauli's exclusive principle. So you can see here, so no two electrons in an orbit, okay, in an atom will have same set of quantum numbers. Means what? The electrons will be filled like this, that is at least one will be anti-parallel to each other. Okay, now here you can see the electrons are, one is anti-parallel, both are here parallel. This is not the way of filling the electrons. Okay, here also both are anti-parallel spins. This is also wrong, right? So Pauli's exclusion principle, okay, the electron should at least means what? Same, they will not have same set of 4 quantum numbers. Okay. Next is Hund's rule of multiple maximum multiplicity. So pairing of electron does not occur in orbitals of the same energy until each of them is singly occupied. Means what? Suppose you have a d shells, okay, d orbital. So if there is d5, means what? 5 electrons are present. So how the electrons filling will takes place? 1, 2, 3, 4, 5. Is it like this, or is it 1, 2, 3, 4, 5? Yes. How in which way the electron filling takes place? The filling of electron takes place by this method. Okay. First, the electrons are singly filled. Okay, the electrons are singly filled in the orbital, and then the pairing will takes place. Okay. So this is about Hund's rule of multiplicity. Then what is half filled and completely filled? So whenever you have half filled orbital and completely filled orbital, they are said to be more stable. Okay, the extra stability, it is due to, so the extra stability, it is due to the symmetrical distribution and greater exchange of this. Okay. So this is about the Hund's rule of maximum multiplicity. So you can see here Hund's rule. Okay, how the filling of electron takes place. First, the electrons are singly filled, and then so this is the correct way. Okay. So first the electrons are singly filled, then the pairing will takes place. Okay. So this is the way you have to fill up the electrons. So we'll solve some questions. So the number of nodal planes, that is planar nodes in 3px orbital, how many are there? Okay. So you have to calculate the planar nodes. How do you calculate the planar nodes? So 3px orbital. Okay, you have to calculate the planar node for 3px orbital. So number of that is the number of nodal planar nodes in 3px will be equal to L. Okay, it will be L. So n is equals to 3. So n will be equal to 2p. So 0, 1. It will be 1. So n is equals to 3. L is equals to 1. Okay, so number of planar nodes, it depends upon the value of n, and that is 1. So that is option number A. Okay, option number A. It depends upon what nodal planars. It depends upon the azimuthal quantum number. Radial nodes, it depends on principal quantum number as well as the azimuthal quantum numbers. But planar node, it depends only on the azimuthal quantum number. So it will be L is equals to 1. So option number A is the correct answer. Then next one. The number of d electrons remained in Fe plus 2, that is atomic number of Fe is equals to 26 ion is A4, B5, C6, D3. So Fe plus 2. Okay, what is Fe? The Fe atomic number is 26. Fe plus 2 means it will be 24, 2 electrons less. So if I write the electronic configuration for ferric, that is ferrous 20, this will be argon 3d6 and 4s2 for 26. Okay, now if I write it for 24, so this will be argon 3d6. So which will so the number of d electrons remain will be 6. Option number C. Okay, the number of electrons which are left will be 6. Next question. The number of unpaired electrons in Fe plus 3. Yes, the number of unpaired electrons in Fe plus 3, that is Z is equals to 26R. A5, B6, C3, and D4. Yes. So again, what is Fe plus 3 they have asked? So Fe is 26. So Fe plus 3 will be 23, right? 23. So I have to write it for 23. So Fe plus 3 will be argon 3d5. Okay, so for Fe will be argon 3d6 and 4s2. So Fe plus 3, so number of electrons are 5. So option number A. Okay, option number A will be the correct answer. Yes, Sri Varuni has answered it right. It is A. Last question. Consider the ground state of chromium atom whose atomic number is 24. The number of electrons with azimuthal quantum numbers L is equals to 1 and 2 are respectively A 16 and 4, B 12 and 5, C 12 and 4, and D 16 and 5. So chromium is what? 24. So number of electrons with azimuthal quantum number L is 1 and 2. Okay. L is equals to 1 means what? It is P subshell. Okay. And L is equals to 2 means it is D subshell. Now, number of electrons. Number of electrons can be calculated as chromium is 24. So it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5. Okay, 3d5. So number of electrons having L is equals to 1. So you have to calculate P subshell. If L is equals to 1, then that is L is equals to 1, then P will be, how many P are there? Just calculate. So P will be 3P and this is there. So it will be 6 plus 6. Okay, so it will be 6 plus 6, it will be 12. So when L is equals to 1. Now, if you have L is equals to 2, L is equals to 2 means you have to calculate D electrons. So there are only 5. So D is equals to, that is number of electrons is 3D will be 5. Okay, it will be 5. So it is 12 and 5. So option number B. Okay, option number B is the right answer. Yes, Sri Varuni had answered it right. Good. Okay, so by this we have completed the chapter structure of atom. Okay, so any doubts here? Okay. So next class, we are going to start with classification of elements and periodicity. Okay. So if there are no doubts, so I shall end the session here. So we'll meet in the next class. So thank you. We'll meet in the next class.